There we go. Let's get started. Okay, so yesterday we looked at the transformation that comes from adding to the quadratic, adding k. Remember, we looked at what happened when you add a k outside. Can you guys recap for me what happens when you add or subtract a number outside the x squared?
Going up?
It's going to go up or
down.
Or down. We call this vertical no translation. Translation means you're moving it all up or you're moving it all down. Remember that? So k, that value that you add outside your x squared, is going to move it up or down. What causes a vertical compression or a vertical stretch? What? In where? Where would it be?
Oh, the zero or less? The zero, what is it? X is less.
Remember the a value, right? So the value that's multiplied by x squared, right? Do you guys remember that?
Yeah.
This is vertical compression.
Vertical compression or vertical stretch. Okay? If you go back to the notes, you'll remember this, but I'll recap them at the end. Okay? Now, what equals x squared? That's your, what do we call this? Parent function. That's your parent function for quadratic. Okay? So this is, everything else is compared to that parent function. Okay? We just, to recap, the parent function will look like this. Okay, I'm going to graph it on Desmos so you see. It looks like this, right? You have your vertex, which is right here at the bottom, right? Is your turning point, and it's at 0, 0. Okay, and it opens up. Okay, now the question is, what happens if I add a value to the x inside the bracket? You see now, we're adding a value inside the bracket, not outside like yesterday. We're adding it inside. We call that value h. Okay, we call it the letter h. Now let's look at the graph of x minus 2 all squared. So compare the two graphs for me. They look the same.
Two right, and one's in the center.
Move to the right. The blue moves to the right. How many units to the right did it move? 2. Where do you think that came from? Why did it move to the right? From there. Because I added 2 to that bracket, or I subtracted 2 to that bracket, it caused my graph to actually move to the right 2. What's my vertex here?
2.
What's that point?
0.
2, 0. Right? That point right here is point 2 because x goes first.
So 0, 2.
0, 2, 0.
Oh.
Right? X goes first, y goes second. Okay? The value of x is 2, the value of y is 0. Okay? Now, what's the second function that I have to graph? X minus 4 squared. Okay? Okay. Describe this for me. Compare it to the red one. Moved 4 units to the right.
So the square does nothing to do with the equation?
The square causes this shape. You see that shape right here? Right? It's like that because of that x squared. Okay? We have done a lesson about x squared, so when you go back to the lessons, you'll be able to see it, okay? You'll be able to see how did we graph this red function, okay? Now, that 4 right here caused the graph to move 4 units to the right. What's my vertex now? What's that point right here? 4, 0. Excellent. So that vertex right here is 4, 0. Now, explain to me what is that H? We call it H, the letter H. What is it doing to the vertex? What is it changing? Is it changing the x value of the vertex or the y value? The x value. Do you remember what does the x value represent? What? Say that out loud. The axis of symmetry, right? So the x value is the axis of symmetry. So that h, that value inside the bracket, is going to affect your vertex, and in terms, it's going to affect your axis of symmetry. Okay? Now, did you notice something a little strange? So x minus 2, we move 2 to the right. X minus 4, we move 4 to the right. So if I have x plus 1, where do you think it's going to move? To the left. So it's going to be like this.
How does that make sense if it's in the minus? Like if
That's a very good question. H, the formula for it is x minus h. Okay? So if you put a positive number in for h, it's going to stay, so it's x minus h, right? If I put a positive value here, it's going to stay x minus 2. It's going to stay as a minus, because minus times positive is minus. If I put a negative number, so if it's negative 1, I will have this. Negative times negative is
Positive.
so it's going to look like that. So whatever you see is inside the bracket, you have to think the opposite of it. Okay? So you have to think, if it's negative 2, that means it's 2 to the right. Okay? If it's negative 4, it's 4 to the right. If it's positive, I have to move to the left because of that negative that I see in my formula. Okay? Only H. The rest stays the same, the A and the K that we talked about yesterday and the day before yesterday. H is the only one that's different. Positive moves to the left, negative moves to the right. Okay?
For the rest, everything moves to the right.
For the
rest.
For the rest, it's not to the right, but everything.
So
Positive is positive, negative is negative.
this is just the answer, like half the answer of the actual equation that we're getting it from?
That's right. So this is only, we're covering this part right
Yeah.
now. Okay?
Alright.
Alright. So, let's graph x plus 1 squared. Okay, so you see that your vertex is negative 1, 0. And what's the fourth equation? Plus 3. And it moves 3 units to the left, and the vertex is negative 3, 0.
So does this mean that the x is going to change, like for axis of symmetry?
Correct.
So it's going to be like x equals 2?
That's right. It's going to be x equals 2, x equals 4, x equals negative. That's right. Okay? So let's go back to the note. And let's fill out this part of the note. Direction of opening did not change, correct? They were all open up?
Right.
Yeah? Okay. So what's the value of H here?
2.
2. That's correct. So remember, it's opposite to what you see. Direction of opening is up because they were all the graphs were looking like this, opening up. The vertex is 2, 0. And the axis of symmetry is x equals 2. And what happened to the original graph? So what kind of transformation did I see? Moves to the right. So it's gonna be called horizontal translation. Horizontal means on the horizon, right? On the x-axis. The other one was what kind of translation? The K. What was it? Vertical. Vertical up and down. Okay? Horizontal means left and right.
So H means left and right?
H means horizontal, which is left and right. Okay? So always think about it this way. H, horizontal. They start with the same letter. Okay? So horizontal. I'm gonna do this. I'm not gonna write horizontal translation every time. And yes, you can write the same thing on the test. Horizontal translation. And I'm gonna write it as HT. Okay? HT represents horizontal translation. So, horizontal translation, 2 units.
You don't gotta tell the first one. It doesn't do anything.
The first one, nothing. That's my parent function. Okay? 2 units to the right. Okay? What's the value of H for the second one? 4. Direction of opening. Vertex. Axis of symmetry. X equals 4. You just got half of the mark because you did not write X equal to. And horizontal translation. Now be careful when you're answering the next question. What's the value of H? -1. Opposite to what you see. Direction of opening. Vertex. Axis of symmetry. And horizontal translation.
To the left.
1 unit to the left.
You have to put 2 there, or can you just put left?
You can just put left. -3. Up. When you say to the left, you just don't have to write the negative. If that's what you're asking. Why did I put -1?
No, because I was looking at something that it says if it's positive, it moves to the left, and negative moves to the right. So it says.
If it's positive, you move it to the left. Okay? Vertex is -3, 0. X equals -3. And horizontal translation, 3 units to the left. So what we've been looking at, guys, we've been looking at the vertex form, at this form, okay? At this form, y equals ax minus h squared plus k, but we've been looking at it in separate windows, okay? We looked at the a x squared first, we looked at the x plus k, and then we looked at the x minus h squared, okay? And the next, we're gonna be looking at kind of combination of all of them together, okay? So it's not gonna be only one kind of transformation, we're gonna see multiple transformations, okay? Now, let's put it all together in here, all right? How does the value of h affect the basic parabola? Okay, parabola is what? What does the word parabola mean? It's the shape of the graph, right? The shape of the graph is like this, right? Or like this. It's called a parabola. That's the name of it, okay? So, when h is greater than 0, how would it look like in your function? When h is greater than 0, how does it look like in there? It looks minus. Okay? When h is greater than 0, then you're gonna see this. Okay? It's gonna look minus inside your equation. The parabola shifts to the right. When h is less than 0, so it's gonna look like x plus h squared, right? And the parabola shifts to the left. The value of h describes the what kind of translation. So describes the horizontal translation of the parabola. It provides the value for the x of the vertex and is the axis of symmetry. I just want to quickly recap this, okay? The parabola is always going to look either like this or like this, right? This is the shape. The vertex is your turning point. The vertex is a point which is x and y, right? The x value of the vertex is the same thing as the axis of symmetry. Can you guys describe what does the axis of symmetry do to your graph? It splits your graph in half, right? So it's over. Okay? Splits your graph. Yeah. So the x value is your axis of symmetry. Now, what does the y value represent? Optimal value. So what is the lowest value that your graph is going to reach? Or what's the maximum value that your graph is going to reach? Okay? So that's your optimal, which means max or min. Okay. New information? New information?
Yeah, just one
So let's look at the following equation, okay? And let's describe the transformation and try to graph it. Okay? What kind of transformation do you see here? Vertical and horizontal, right? What letter does this represent? What letter does it represent? H. What letter does this represent? K. You'll see them. You'll get to know them, right? Because A is at the beginning, H is in the bracket, K is outside. Okay? So H causes what again? Horizontal translation, right? K causes what? Vertical translation. So, what kind of horizontal translation I have here? Horizontal translation, how many units? 2. 2 units left. What does 3 cause? Or negative 3?
Vertical translation dash.
How many units?
3.
So 3 units down because it's negative, right? Okay. What's your vertex?
Vertex 2 and 3.
Negative 2 and negative 3. Okay, I want you to go back to the note that we just did, right? We just said that h is going to be the x value of the vertex, right? And we said yesterday that the k is going to be the y value of the vertex. Okay? So, h is the x value, so that's negative 2. And so remember, it's opposite what you see. And k is the y value, which is negative 3. So your vertex is negative 2, negative 3. Very important. You should be able to, when you see this, you should be able to locate the vertex right away. Because the vertex is very important for graphing. When we locate the vertex, what do we follow?
The step pattern.
Step pattern, which is
1,
1, 3, 5, unless I have an A, then it will affect it. But because I don't have an A, it will be 1, 3, 5. Okay? Step pattern, I'm gonna write it down. One, 3, 5. Okay. So, first thing you have to locate is the vertex. So the vertex is at negative 2, negative 3. So the vertex is at negative 2, negative 3. Remember guys, x, y. Okay? So you have to locate this at the x, and then you have to go to the y, which is negative 3, and then whatever that means, that's your point. Okay? Negative 2, negative 3.
They must meet each other.
Yes. Okay. Now the step pattern says you're going to go up 1, over 1, right? So from the vertex, you're going to go up 1, over 1. Over to both sides, that will be your next points. Okay? I'm going to repeat that. Up 1, over 1. You're going to go over 1 to both directions. Now, from that point, the step pattern, what does it say next? How much do I go up?
Up 3.
Up 3. You're always going over 1, okay? So up 3. 1, 2, 3, over 1. 1, 2, 3, over 1. After that, how many points do I need to go up? 5, because my step pattern is 1, 3, 5. 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5 over 1. And then all what I have to do is I have to join these points in a smooth curve that we call a parabola. Yes.
Did you do those steps for the first, like, -2?
For the first point,
Yeah.
so from the first point, right, using that vertex, I'm gonna start moving away from that. Okay?
Oh, I
So
see.
I go up 1 over 1, I locate my next point.
Yeah.
Okay? Then from that point, I have to go up 3 over 1.
I was looking at the wrong dot.
Okay? Does that make sense?
Yeah.
Okay. So, is that okay?
When you are going over 1, you just take a movement up and then to the left or to the right, depending on what which unit it is.
So if I'm moving from here, I'm gonna go up 3 over 1 to the right. If I'm moving from here, I'm gonna go up 3 over 1 to the left.
So you're just duplicating what you did on one side.
Exactly, right? Because of my axis of
Symmetry.
right? Because that's when if I fold both of them on top of each other, if I actually cut this in half and fold them, they must overlap because of that symmetry. Okay? So you're gonna do exactly the same thing with this equation. You're gonna list the transformation, vertex, step pattern, graph. Okay? Try it. Match with the person sitting next to you or in front of you or on your left, on your right, whatever. And then we will take it up.